global silicon landscape is fracturing. We are hitting a massive $600 billion wall, not because we can't make chips fast enough, but because we can't power and cool them. As the era of simple GPU scarcity ends, a much more dangerous bottleneck is emerging, one that involves the sheer capacity of our electrical grids and the extreme demands of high-density liquid cooling. Enterprises are now realizing that raw compute is no longer the primary currency. Instead, the real power lies in the ability to sustain massive energy for model inference. The transition to high-bandwidth memory 4 is fundamentally altering how reasoning agents process complex datasets across the most advanced planetary-scale cloud clusters. Nations are now racing to secure sovereign infrastructure because relying on external data centers is becoming a critical risk for national security and economic growth. We are witnessing the death of general-purpose cloud computing as specialized artificial intelligence silicon takes over the entire global digital transformation roadmap. Today, we will dissect the architecture of this $600 billion computing crisis and explore how decentralized, edge-hybrid systems can save your operations. You will master the technical shifts in memory architecture and learn why high-bandwidth memory 4 is the key to unlocking true agentic reasoning. By the end of this deep dive, you will possess the strategic framework to navigate sovereign infrastructure requirements and global power and cooling constraints. I am your lead architect, and we are bridging the gap between theoretical research and the hard reality of scaling industrial artificial intelligence systems. The legacy data center model is collapsing under the weight of generative workloads that require 10 times more power than traditional search engine requests. In 2026, the primary pain point has shifted from buying chips to finding enough megawatts to keep the massive server racks running. Industry leaders at Microsoft and NVIDIA are sounding the alarm as the physical limits of copper and electricity begin to stall model scaling laws. We see a world where compute is the new oil, but the refineries are struggling to keep up with the sheer heat of processing. Without a fundamental shift in how we architect these systems, the dream of artificial general intelligence will remain trapped behind a massive power wall. The geographical concentration of compute in North America is creating a global imbalance, forcing Europe and Asia to build independent, sovereign clusters. Current benchmarks from Hugging Face and AR14 show that model efficiency is now more important than raw parameter count in this resource-constrained era. We must transition from a mindset of infinite growth to one of strategic digital resilience and high-efficiency computing to survive the coming year. So how do we navigate this? It comes down to 4 actionable pillars. Pillar 1 focuses on the transition to high-bandwidth memory 4, which allows reasoning agents to process information at speeds previously thought completely impossible. Technical research from the Vector Institute suggests that memory bottlenecks are the single greatest hurdle for the next generation of deep learning model architectures. In Canada and the United States, engineers are redesigning the interface between the processor and the memory to reduce latency and improve overall throughput. This shift enables complex reasoning chains that allow artificial intelligence to act as an autonomous agent rather than just a simple text generator. Pillar 2 addresses the strategic return on investment for decentralized compute architectures that utilize edge cloud hybrids to reduce the central processing load. Global firms are moving workloads closer to the data source in Europe and Japan to mitigate the high costs of centralized, massive cloud infrastructure. By distributing the inference load across a wider network, organizations can maintain high performance while avoiding the catastrophic failure of a single power grid. Digital transformation now requires a flexible approach where sovereign clouds and local clusters work in perfect harmony to ensure continuous and stable business operations. Pillar 3 explores the intersection of cybersecurity and post-quantum defense as we secure the massive data pipelines fueling these new sovereign computing clusters. The EU AI Act and ENISA guidelines demand that we build trustworthy systems that are resilient against adversarial attacks and complex, automated phishing attempts. Securing the hardware layer is now just as critical as the software, as side-channel attacks target the very silicon doing the heavy lifting. As we move toward 2027, protecting the integrity of the model weights and the data privacy of the users is the ultimate priority. Finally, Pillar 4 outlines the implementation framework for global governance and the ethical integration of these massive systems into the existing labor market. The OECD AI Policy Observatory provides the data needed to ensure that our infrastructure investments align with global standards for safety and human potential. Leading research from Fraunhofer in Germany shows that industrial AI must be transparent and explainable to be accepted by the global manufacturing workforce. Successful governance ensures that the benefits of this information revolution are distributed fairly while maintaining the competitive edge of the early technical adopters. Now let's make this real. To visualize this new architecture, we must examine the latest GitHub repositories focusing on decentralized inference and the optimization of high-bandwidth memory for protocols. The architectural prompt involves configuring a hybrid cloud environment that automatically shifts workloads based on real-time energy pricing and local thermal constraints. We can utilize open-source tools from the European AI Alliance to benchmark our system against the most recent standards for energy-efficient computing. By analyzing the NIST risk management framework, we ensure that our deployment is not only fast but also fundamentally secure against the latest threats. This practical application allows us to turn theoretical sovereign infrastructure into a functional asset that powers the next generation of industrial-scale neural networks. Witness how the integration of localized cooling and specialized silicon reduces the total cost of ownership by 40% in modern, high-density environments. So, let's bring it all together. The connection between power availability and the future of reasoning agents is the defining challenge of this decade for every global technology leader. When we synthesize the need for sovereign infrastructure with the advancements in memory, we see a new blueprint for sustainable and resilient digital transformation. The aha moment arrives when you realize that compute is not a commodity but a strategic resource that requires careful planning and ethical governance. By solving the cooling and power crisis, we unlock the potential for artificial intelligence to solve the most complex problems facing humanity in 2026. Your roadmap for the next quarter must include an audit of your current compute efficiency and a strategy for adopting decentralized, hybrid architectures. Follow the research from the India AI Impact Summit and SoftBank to stay ahead of the curve as the global power landscape shifts rapidly. Join our community of architects as we continue to map the frontier of sovereign neural technology and the future of the digital global economy. Turn knowledge into your greatest asset. Thanks for watching, and don't forget to subscribe.